This demo shows the VI-WorldSim offline capability to integrate with MATLAB Simulink. Let's start in the WorldSim Studio by building a simple scenario on a straight road. We have an ego vehicle in the right lane and a traffic vehicle on the left. The ego vehicle will be driven by a VI-CarRealTime vehicle dynamics model. We have a set of virtual sensors, one camera and one virtual camera. Let's save the scenario and close WorldSim Studio. The WorldSim offline package contains three main components. The first is a set of 4 scripts to start WorldSim, load scenarios, unload scenarios, and stop WorldSim. The second main component is the executable components for WorldSim process itself. Let's run a script to launch the WorldSim offline process and load the scenario we just built. The third main component is a library of WorldSim related utilities. Here we open a simple example Simulink model. You will find inside the Simulink library browser a VI-WorldSim library. The library contains a utility for syncing the Simulink and WorldSim processes. There's a block for sending data from a VI-CarRealTime to the WorldSim environment to be used by the ego car. And then there is a complete set of sensor blocks. For example, the camera, virtual camera, radar, LiDAR, and so on. In this example, we have a VI-CarRealTime plant model for the ego vehicle. The model is based on a simple sedan vehicle send file that we distribute in the installation directory, which of course could be replaced with your own model. You can then manage the input signals to the VI-CarRealTime plant model. In this case, we use just the driver demand steering input. For our output, you can export through a virtual bus all the channels that are produced by the VI-CarRealTime model. So the data flow is the VI-CarRealTime block is computing the vehicle dynamics and is sending that to the WorldSim ego vehicle. The block of the controller is synchronizing VI-CarRealTime and the VI-WorldSim environment. On the right, we have a sensor block. In this case, it's a virtual camera. If you double click on it, you can set the options. For example, you can set the WorldSim actor that the sensor is attached to, which we want here to be the ego vehicle. You can then select the sensor name in WorldSim that this block in Simulink is associated with. There are some additional parameters to manage the number of outputs. You can see that there are a number of potential outputs from the virtual camera sensor. For example, we selected export of a polynomial coefficients for the left and right lane. In this case, what we have done here is to produce a very simple lateral controller in Simulink in which we grab the lane polynomials as input and export the steering command to feed the VI-CarRealTime plant. This closes the data loop. So when we now run the simulation and we go to the WorldSim environment, we see that there is a simulation where the vehicle tries to stay inside the lane. Obviously, then, it is a matter of tuning the lateral controller to make it smoother and better than this. This completes the example of offline integration of WorldSim with MATLAB Simulink.